working on section 4.1, which is about exponents and using a different format for multiplication that maybe is just like using a repeated factor. We're going to learn a different format for writing that. We're going to be starting today on workbook 52, which I know it's labeled as homework in your workbook, but we're going to be using that as our classwork side. It's more difficult. And then I'll let you do the 51 part independently for homework. Okay, so we're doing a little bit of flip-flop today. I need you on page 52. And if you're joining us from home, please type your name into the chat box so that I can take attendance. And those of you at home, you really should have your camera on because this is like participating in a class session. I should be monitoring your progress throughout. Please turn on your camera if possible. And I'm going to be sharing my screen with you so that you can see what I'm up to, okay?
Can I show you something?
So this is the worksheet that we're going to be working on during our class today. And I'm going to be trying to annotate right here on top of the screen. So I'm going to need your help for a second as I explore using this particular tool in this classroom, okay? So let me see if I can get my annotate features to show up here. I want to get down to this page here. Oh, I'll just use my Zoom one instead.
That one didn't work last time.
Yeah, okay. I'll use my Zoom annotate tools instead. So if on page 52, you're going to notice that there is a new way of looking at repeated groups of numbers. This style of an expression is just an expanded form, and we're going to condense it into something called exponent form. We're going to be counting up the repetitions of the factor and then using an exponent to determine how many copies of that number you have. So I would prefer to just get right into the assignment to help our study here. If you can go to 52 now, and we're going to start writing, so have something on hand. I'm going to go over to the board now. And online people, if you cannot see this, please let me know, okay? Got it over here. And when we are looking at this first problem, we can see that the number 5 is repeated 4 separate times. So I have 4 copies of the number. Can I teach? I have 4 copies of the number 5, right? So 5 is the number that's featured, and I have 4 copies of it. So I'm going to use 5 as the base and 4 as the exponent. So on number 1, I want you to just write 5 to the 4th power. This is lovely that it's not lining up here. This is just lovely. Isn't it? We're just blended. It is splendid that we're not
We're just not used to color. I haven't every day with this set of words.
Here, let's see if we can quickly.
But it's worse in the sense where it gets an highlighter. And then it turns the whole screen black.
Here, we're going to try and calibrate this real quick so that I'm not writing on all different papers.
Oh yeah, Miss said we're trying to do it. We should know how to get it.
Okay. It should be good now. So getting back to what I was trying to do in the first place, that's a little better.
It's a highlighter. Oh shoot.
But that's a highlighter. So we'll do this one. 5. Ooh, look at that, to the 4th power. Everyone give me a hand. The next example, which factor is repeated? What's the name of the factor that's repeated, class? N. And N is the base. And then I have to count up how many copies of N do I have. So go ahead and count those up.
1, 2, 3, 4, 5,
8 copies, did I hear?
Yeah.
8 copies, so 8 is gonna be your exponent value. Now, since we have a little bit of extra space here in this area, I want you to use a different color right now and label, like a little diagram, that the number that is really tiny in the superscript is called the exponent. Let's label that exponent. And the bigger factor that's written with regular size writing is called the base. And the base tells you what factor you have a copy of. The exponent tells you how many copies of it you have.
The end of the base.
Mhm. What would the base be for this first example here? 5 would be the base, and 4 would be the exponent. No, it doesn't matter what color. I just wanted you to take a moment to diagram your work a little bit. When the next set of instructions asks for the standard form, we have to calculate what is the one number answer. She is in room 201 right, or 202 right now.
Oh, wait, what was that?
201,
Thanks.
I think. We're gonna find out the one number answer for the standard form here, okay? So we're gonna be calculating what is maybe for number 5, 2 times 2 times 2 times 2 times 2. Or for number 4, what is 1 times 1 times 1 times 1? We're gonna actually figure out that. But in order to do that, sometimes it helps to put it in expanded form. What do I mean by expanded form? Put it in that stretched out format where you see factor times a factor times a factor times a factor, depending on how many copies of it you need. So if you look at number 3, how many copies of the base x do I have? How many copies of it? Just 1. So I'm going to write x by itself. And are there any other copies of it? That's the answer for number 3, is I have 1 copy of x, and there's no way I can determine a value for x because I wasn't given a value. I was just given that, why can't I think of the term? Variable. I was just given that variable, and that's all. So the answer for number 3 is just x. What if it was x to the second power? It'd just be x times x, right? Or you could say that the answer would be x squared. Squared, you don't know what I mean by squared? Okay. X squared means to the second power. And what do you think this is called with a little 3? Have you ever heard that before? What is it? What is it? Cubed, yeah. Yeah, you haven't heard those terms before? Okay, well, that's a good opportunity for us to label. So when it's to the second power, guys, we call that squared. Are you writing this on your workbook? Yes, Mrs. Moore, we are. Yes. Everyone at home writing this on their workbook? And when it's to the third power, it's called cubed. Whoa. Look where that came from. Third power is called cubed. Second power is called squared. Now think about a square. How many dimensions does a square have? 2, right? A length and a width. Think about a cube. How many dimensions does it have? 3, a length, a width, and a height, right? So that can help you remember those 2 standards. Here, I'll try and draw a square there. Here's a cube here, right? 3 dimensions, 2 dimensions for a square. Got it? Moving on to number 4. It's like saying I have 4 copies of the factor 1. So it's like 1 times 1 times 1 times 1. What is 1 times 1 times 1 times 1? Go ahead. 1 easily. So I just put equals 1, circle the 1. What would 1 to the 754th power be? Class? 1. What would 1 to the 9 millionth power be? 1. When I say to the power of, what am I meaning? That little number, that exponent value. So you can use the phrase to the power of, and it tells you what that value is. So one more thing to add to your notes. when you hear the power of, it's talking about what? The exponent value. Everyone at home seeing this on their screen? You're seeing all my writing, correct? Yep. Awesome. Okay. So when you hear the power of, it's referring to the exponent. Let's try saying this next one by using that phrase, the power of, okay? So what is the base? State the base. For number 5, what's the base? 2 to the 5th power. Everyone say it with me again. 2 to the 5th power. Okay, so let's do 2 to the 5th power. It means I have 5 copies of 2. Now let's calculate that. What is 2 times 2, class? Times 2 more. Times 2 more. Times 2 more. 32, exactly. Great job. So 32 is the standard form of 2 to the 5th power. All right. This is a tricky scenario when you have something to the exponent with a 0 or to the 0 power. What that means is you don't have any copies of D, but you do have the remaining factor that makes it true for its identity property. What is the remaining factor that you need to make the identity property true? What is the number that goes with every single factor? D times what makes it just D? D times what? 1. Yeah. So if I had no copies of D, see how it says 0? No copies of D, what factor do I have? 1. The answer of anything to the 0 power is 1. So it could be, 10,403 to the 0 power. What would the answer be? 1. Anything, any base to the 0 power is 1. So I'll give you a minute to maybe document what I have here on my workbook page. This factor D splits into D and a factor of 1. I have 0 copies of the factor D. What am I left with? I'm left with 1. That's why 1 is the answer. Okay, moving on here to number 7. The 5th power of 3. So which one is the base and which one is the exponent? So remember that word power refers to the exponent value. So for number 7, which one is connected with the word power? The 5 or the 3? The 5, the 5th power of what base? 3. So let's write it. 3 with a tiny 5. This is exponential form. It's exponent form. What do the instructions want? Standard form. So what do we have to go do now? Actually find what 3 to the 5th power is equivalent to. How do we do that? How do we do that?
Now 3.
Go ahead. Yeah, go ahead, Kay. We expand it so that we can see all of those factors in motion. Please do not think that 3 to the 5th power is 15. That's the biggest mistake kids make on working with exponents is they try to multiply them and be done. Doesn't mean 3 times 5. It means 5 copies of what? 3. Now that's a big number to calculate, but there are ways to make it easier for yourself. Because multiplication is commutative, can you reorganize or regroup? It also has that associative property. You can group together factors that would make it easier for you. You guys know 3 times 3 is 9, right? So what if you said, okay, well, here's a group of 9, here's a group of 9. That's easier to multiply than 3 times 3 times 3 times 3 times 3, right? Then you would say 9 times 9 times 3. What is 9 times 9, everyone? 9 times 9, 81. And then all you have to do is 81 times 3, right? And that's a lot easier to calculate than in your head 3 times 3 times 3 times 3, right? What would that result be? 243? Okay. As time goes, your brain is going to start remembering like 2 to the 5th power. It's going to snap out of just like a calculation that you won't even have to make anymore.
How is it not 15? I don't get it. It's 3 times 3 times 3 times 3.
Because what is 3 times 5? 3 times 5 is 3 plus 5, or 3 plus 3 plus 3 plus 3. It's not times. The operation is different. When you have 3 times 5, that means I'm repeating at addition. When you have 3 to the 5th power, what are you repeating? Multiplication. That's a good question. That's how you can help yourself differentiate the two. Yeah, this is, now here's that word square again. Remember we came across that? What does square mean? It means to what power? To the 2nd power, right? So squared, remember, means to the 2nd power. So let's write this in exponential form. 6 is the base, 2 is the exponent. Now let's write it in expanded form. 6 times 6. What is 6 times 6? It's not 12.
36.
It's 36. You got it. Train your brain. It's not 6 plus 6. It's 6 times 6. Yeah, exponents are repeated multiplication, not repeated addition. Okay, next set of problems here asks us to write in exponential form. So that's the form where you have a base and an exponent, a base and an exponent. So let's write the base and the exponent for number 9. The 6th power of y. What is the base? Y is the base. And what's the exponent? 6. Y to the 6th power. That's it. What's the exponential form for number 10? It says the square of 10. So to the 2nd power, remember square is a 2-dimensional shape. And so that means go to the 2nd power. If I wanted to find the standard form value of this, would it be 10 times 2 or 10 times 10? It would be 10 times 10. It's 2 copies of 10 multiplied together. 10 times 10 makes 100. Hey, here's a cool connection. Place value chart. On the place value chart, isn't 100 next to, wow. Oh, what isn't 100 next to 10 to the 2nd power? Isn't it? Lined up? How many zeros are in 100? 2, right? Is it the 2nd? Exactly. It's the 2nd power of 10. Okay. This last section is a little tricky because now you're determining the missing exponent. So you're determining how many copies of that value make that statement true. The first one, I want to remind you about which exponent always makes things result in 1. Which exponent makes things result in 1?
0.
0. Yeah, so n in this case is going to be equal to 0. Because when you have an exponent of 0, that means that I have 0 copies of 10 as a base factor, but I still have the copy of 1 as a factor left over. Okay? So 0 is the answer for the first one here, number 11. Number 12. Okay, so how many copies of 6 would it take to build up to 216? So let's see. 6 times 6, that's 36. That's not enough. How about one more? 6 times 6 times 6. You might have to do some multiplying off to the side. What would 36 times 6 be? 18, 19, 20, 21. Hey, it's 216. So how many copies of 6 did I have? 3. So the n value, the missing exponent value, is 3. 6 to the third power equals 216. Do you think you could wait till I'm done with 16 and then go? Okay. How many copies of 6 caused it to equal 216? How many copies? Counts being disruptive during my class. Can you go throw that in the trash, please? So that you don't hurt yourself, or I don't hurt you with the ruler. Dear child of mine. Thank you. Yes, Izzy.
What is it? Like, what is it in that word go like this?
I'm never going to give you a circumstance where that base factor isn't a multiple of your end result. You aren't learning partial exponents or anything like that in 6th grade, okay? So there'll always be a copy, a factor of an even whole number. You're not going to have like a fractional amount or remainder, nothing like that. So you just keep on multiplying. How many copies do I need to reach this total? Okay, let's try it again. How many copies of 5 would you need to get to 5? Just 1, right? So in this case, the exponent would be 1. 5 to the first power equals 5. I have 1 copy of 5. What's the result? 5. How many copies of 10 would I need to get to 100? What do you think? 2, right? 10 times 10. So I'm going to put n, it's got to be equal to 2 in this case. How many copies of 3 would I need to get to 27? I know 3 times 3 is not enough. That's 2 copies. How about 1 more copy? Is 3 times 3 times 3 enough? Yes. So in this case, I need 3 copies of n to get to 27. Oh my goodness gracious. How many copies of 4 will I need to get to 4,096? Now, you might be thinking, that's going to be a big number, but think of how quickly 6 got to be 216, just 3 copies. Look at how quickly 10 got to be 100, just 2 copies. So it won't be long before we get to 4,096. Let's try it out. So I know 4 times 4 is not enough. That's just 16. What's 1 more copy of 4? Would be 16 times 4, which is 64. So that's not enough, right? What if I did 64 times 4? Actually, it's supposed to be 16. Oh, wow.
5 people.
I'll go check into that. Keep going. Keep multiplying, guys. Keep multiplying. Oh, there's no one in the waiting room, but there's some chat going on. So you guys, oh, I see Ryan giving me the multiples. 4 and 4, 2 copies of 4 would be 8. Okay, let's keep on going. How many copies of 4 is it going to take? Maybe use your multiplication charts in your notebook to help. 8. 8 copies?
I don't know about that.
Maybe 8? So let's try. Well, that, oh my goodness. This is not cooperating today. Well, I know 64 times 4 is not enough, and that would have been 4 copies, right? How about we do 64 times 64? That would be like saying 64 times 64 would be 6 copies of 4. Anyone want to do that real quick? 64 times 64. I'm running out of space on my paper here. I'll do 64 times 64 up here. Doesn't look like my computer is going to like me doing 64 times 64. Someone else do it on their paper. 64 times 64.
4,096.
4,096? Is it it? Oh, yeah. All right, here, I'll just write that up here. So what I heard from John is that I know 4 times 4 times 4 is 64. And again, 4 times 4 times 4 is 64. And if I multiply 64 times 64, I know that it's going to be 4,096. So let's count up how many copies of 4 did I need to get to that product. 1, 2, 3, 4, 5, 6. So n equals 6. Whew. Okay, to review.
Are we doing the problem solving?
Not just yet. No, we're not going to do that one today. When we build on this content the next couple days, we
Looks
will.
like long.
To review, and I'm going to pull out my highlighter now. Ready? The larger number featured is called the base. The tiny number that's written up above is called the exponent. You can also call the exponent by saying the power of when you're announcing how many copies of the factor you have. So let's practice saying this one right here. 2 to the 5th power. Everyone say it. Everyone say n to the 8th power. Everyone say d to the 0 power. Everyone say y to the 6th power. Okay, now let's review over here. When you have an exponent of 2, we can call that what? Squared. When you have an exponent of 3, you can call that cubed. Whenever you have an exponent of 0, like we did over here with number 6, what will the result always be? The result will always be 1. Same with over here, number 11. D 10 to the 0 power resulted in 1. Anything to the 0 power ends up with 1. Okay. I think that you are now able to move back. Oh, let's turn off the annotate. Move back to your homework. Yep. Well, I did the homework side because I thought it was a little more complex than the classwork side. But let's take a look at the front on 51. Yeah, this page is going to be your homework. So let's go through and call attention to some things that we were talking about during our class. I have my highlighter tool here. So what is the factor base for number 1? What is the actual base that we are duplicating? 3 is the base. Let's write that. And how many copies of 3 do I have? So it's going to be 3 to the 6th power. Good job. That's the only one I'm doing for that first section. I'm going to do a couple here down on the next section. Anything to the 0 power becomes what, class? 1, right? Rather write that with a thicker pen. Okay, let's do another one. 3 to the 2nd power means exactly what? If I wanted to describe that in expanded form, what would the expanded form be? 3 times 3. Now give me the standard form of that. What's 3 times 3? 9. Okay, I think you can handle the rest there. Let's go down to 22. I'm just going to highlight a couple words here. Cubed means what power?
3.
Square means what power? 2. Square means what power?
2.
Cubed means what power?
3.
Cubed.
4.
Square. What's the power here?
4.
What's the power here? You got it. So the only thing I want you to be attentive to now is in these, you're doing standard form, which means give me an actual number answer. But if you are down here, you're writing an exponential form, which means you're going to have a base number with an exponent little guy upstairs. Do you like my terminology? A big boy base is an uppercase B and a little exponent letter upstairs. Okay? So for the next 8 minutes or so, I'm going to be observing your work on the homework page here, which is page 51, and I'm available for questions here for your online group as well. So if there are any additional questions, I can take them at this time, okay?
Mrs. Moore,
Yes.
so when you're doing exponents, can you like flip them? Like for number 15 on homework, can we do 4 times 4 and it would get the same answer?
Try it out. What do you think? Is it the same to say 2 times 2 times 2 times 2 as it is to say 4 times 4? Maybe occasionally that works, but does it work all the time? Think of a number that it doesn't work for. So for the circumstance you told me, 4 to the second power and 2 to the fourth power end up being equal in value. That's
Okay.
true. But that's not always true. Like maybe try,
Like 11 and 14?
yeah, look at a different one. Like look at number 9. 13 times 13 is 169. But if you had 13 copies of 2, 2 times 2 times 2 times 2 times 2 times, that would be way, 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 way bigger, right? So it won't always work, but good catch on number 15 that it does occasionally have the same result.
Okay.
Miss Moore, I don't get number 11.
Okay. Let me look at it. 5 to the third power, that one. You're looking at 5 to the third power? Okay, I'm gonna go back to my screen share and I'm gonna write on the page here. So 5 to the third means I have this number 5 as my base and I have this many copies of it, right? So if I wrote that in expanded form, it'd be like saying 5 times 5 times 5, 3 copies of 5. Wow, I'm really good at writing on this. I'm using the computer mouse for this. So 5 times 5, can you do that part? Is that Paige? Was that your voice I thought I heard?
Yes.
Okay, so what would just 5 times 5 be?
25.
Okay, good. And then you'd have to multiply 25 times 5, right? So maybe you need to do a little calculation off to the side to figure out what 25 times 5 is.
I got 125.
Okay, yeah, that's right. Because if you think of 25 relating to quarters, if you had 5 quarters, how much would that be worth? 125 cents, right?
Yes.
Yep. So you're all set with that one.
Okay, thank you.
Yep.
So it's the power five, so we can find the base. Because I just wrote it out. This one, you don't have to solve it. You just have to write it and just form out when you're done. I didn't solve it. Yeah, for standard form, you have to solve them. And then you highlight that and then solve, so that you know to find an answer. For exponential form, all you have to do is base exponent.
Which is easier to do, exponential form or standard form? Exponential form, way easier. All you have to do is write the base, write the number. That's it. But for standard form, you have to actually calculate what that answer is. Ooh. How are we doing over here? The result of that.
Me too. You solved all of these? I'm just joking.
I thought you guys did a great job on this. Keep building on, we're gonna continue working on this week. We're gonna start to introduce and revisit a little bit of order of operations. PEMDAS, please excuse my dear Aunt Sally. We're gonna be doing that a little bit this week. All right? Oh, I missed some messages. Here we go. Yeah, it looks like, yep, we were just doing that homework page on 51, guys.
Can we put ask my math?
And then we're gonna be all finished for the day. So yes, I have another class beginning here in 2 minutes, so I'm gonna be on my way, but no, thank you. But it's nice to see all of you. Let me know if you have any other questions. Mrs. Doherty has Zoom math help tomorrow for you guys at 2 o'clock. But besides that, I'm going to be posting a video tomorrow morning describing a little bit more in detail an approach I like to take for order of operations. Okay, so stay tuned. I will see you tomorrow.
Can I show
Have
you
a good
something funny?
afternoon. Bye.